There's a video for AQA Discrete Mathematics. This is Graphs and Networks section 3.2, where we're looking at network flows. Well, here we have a directed network, and I'd like you just to sort of think for a minute or two what this might represent. A couple of things to notice is that the arcs coming out of S are both forward facing, and the arcs coming out from, or into T rather, are both coming in, none going out. So we have what we call a source S and a sink at T. Now the rest of the network, the arrows have all got some numbers on there, or the arcs have got some numbers, some weights which represent something. It could, for example, be traffic flow through a system of one-way streets. It might be numbers of people who can move through corridors in an office block. All sorts of things where we have a flow from one point to another point. Now what we're going to try to see is there some way of achieving a maximum flow through this, or what is the maximum flow? Well, to start off doing that, we're just going to look at, well, is there what we call a feasible flow? Are there some values that could go onto here? So the grade numbers there are what are termed the capacities of each of the arcs. So for example, where that from S to D, we might have 6 flowing along from S to D, and if you see when it gets to D, it's got to split. So for example, it might split so that we have 4 flowing from D to C and 2 from D to A. Clearly if 6 go into D, 6 have got to come out. Well, we might have 6 coming from S to A, which now we can see we've got a total of 8 coming into A. So let's say that those 8 all go along from A to B. In fact, they have to, because then we're going to have nothing perhaps coming down from C to A. So what's happened to the 4 that have gone from D to C? They may well split, for example, 2 in each direction. And then if you look at B now, you can see that the 8 and the 2 that we've put in there must combine together to give us 10. So there we have a flow through that network of total 12. You can see we've got 12 coming out from S, 6 plus 6, and 12 going into T, 10 plus 2. Now the question then is, can we increase that? What's the maximum? So the network then, there's one source and one sink in this particular network, and we've already discussed the idea that there's no build-up at any other node, so that whatever flows in to a node must flow out. Now with our flow of 12 that we had a minute ago, is there any way that we can increase that? Well, clearly if you look at the possible total that comes out from S, we've got 8 and 10, so possibly we could have 18 coming out of there, and 7 and 15, it's possible for 22 to flow into T. But does that mean that we can actually get 18 all the way through from S to T? We've achieved 12. Can we do a little bit better than that? And that's really what we want to know. What is the maximum that can flow through this network? And in the next video we'll be looking at a theorem which allows us to see whether we have a flow which is a maximum or not. So in that next video, 3.2, we'll be looking at the theorem to do with cuts and minimum cuts. And this is the end of the video on network flow introduction.